All right, this is going to be a walkthrough video of the Exam 1 review. And as a reminder, you will have a different numbers, different values than I do, but you can follow along the same process that I'm using to get your answers. So for number 1, we have a graph of the number of species for various kinds of insects. And I wanted to point out one thing because the most common mistake on this problem here is that this number, right, this number right here is in thousands. All right, the number of species is in thousands. So whenever you have a graph, you always want to make sure you are checking the labels. So what this means is that all of these numbers have what, 3 zeros on them. So this is 300,000. This is 270,000. So all these have 3 zeros. So this is 300,000, 270,000, 190,000, 130,000, and then 100,000. All right, so this is something that I wanted to point out before we start working on this problem. Now, let's take a look at the first one. How many more beetles are there than true flies? So first, we're going to start with the number of beetle species, which is 300,000. And then the true flies, which is the purple, is 130,000. So when you take the difference between these two numbers, you end up with 170,000. So when you are typing this in the box, you want to put 170 with 3 zeros. If you just put 170, it's going to mark it as incorrect because the label is what? Thousands. Okay, the number of species is within thousands. Now the second one we are looking at the total number of species for all the insect types. So this is the same as adding all these number of what species. This is finding the total number of what species. So adding all these insect types together. So we have 300 plus 270 plus 190 plus 130 plus 100. And that gives a total of 990. And remember, because it is in thousands, when you are typing this in, you have to add your 3 zeros. Now for C, how many fewer beetle species are there than species of the other insect types? So here we are looking at the other insect types. You're going to find the total of the other insect types. And the total of the other insect type is everything excluding the number of wood beetle species. So we have the other insect types. This is the 270. These are the other insect types. 270,000, 190, 130, and then 100. So you find the total of that. Which is 690,000. And then, okay, we have to subtract the 300,000 beetle species. from that, which is 390,000. All right, now another way you can also solve this problem is you take the 990,000 that you found on part B, and then you subtract the number of beetle species twice. So 900 minus 300 minus 300 gives you, sorry, 990, excuse me, not 900. So 990, okay, minus 300 will give you 390,000. All right, question 2. We want to write this number in standard notation, and standard notation is how we normal people write numbers. So 72.3 million in standard notation. Now million is times 10 to the 6. So we're going to move our decimal point 6 places to the right. All right. So 1, 2, 3, 4, 5, 6. And you fill these hands with what zeros. So this in standard notation, 72.3 million in standard notation, you're going to add 5 zeros because the decimal in the number will reduce the 0 by what, a 1. Right, for 3, we have to figure out the best buy, okay? So we have 2 things we are comparing to figure out which one is a better buy. And a better buy is always the cheaper option. So the first option we have, okay, this is already computed. Okay, this is already $1 per gallon. So that's the unit price right there. Now, the other option is what we have to find. Okay, we have to figure out the unit price. If you are filling a 15-gallon tank of gas for 49.39 cents, how much are you paying per gallon? So you take the total price, which is the 49.39 cents, and you divide by the total number of gallons, which is 15 gallons. And dividing these two numbers will give you the unit price, and then you compare that with the 3.40 cents per gallon. So nearest cent, we have 3.29 cents per gallon. And if you compare these two, which one is the cheaper option? All right, the cheaper option is 3.29 cents per gallon. So the better deal, which is also the cheaper option, is the 15-gallon tank for 49.39 cents, because to fill a 15-gallon tank of gas for 49.39 cents, this is 3.29 cents per gallon. All right, next we need to find the ratio as a fraction in lowest terms. If you have your calculator, you put 90 on top. All right, when finding ratios, the quantity before the to statement will always sit on top of the fraction, and the quantity that comes after the to statement will always sit at the bottom part of the fraction. So you have your $90 on top, and you have your $30 at the bottom. Dollar sign will cancel out. And now we need to find the reduced form. And so the reduced fraction is 3/1, which is the same as 3. So since it is asking for a fraction, I'm going to put this as 3/1. All right, the next one is 2 days to 12 hours. We have to write this as a ratio in its lowest terms. So as always, the quantity before the to statement will always be on top, and the quantity after the to statement will always be at the bottom. But here we have what unit. You have to always check that. In order to make a fair comparison, you have to make sure the units are the same before you divide. So days and hours are two different things. So one way we can look at this is by keeping the days in what hours. All right, keeping all of them in what hours. So 2 days, 2 hours. We know that for a day, we have 24 hours. We have 24 hours in a day. So if you are given 2 days, how many hours is that? So this is 2 times 24, which is 48 hours. So now we have 48 hours. Okay, we can rewrite this ratio as 48 hours to 12 hours. Okay, your 2 days is 48 hours. So you have the same unit now, so you can divide. You put your 48 hours, which is your A quantity on top. You put your 12 hours, which is your B quantity at the bottom. Hours will cancel out. And if you divide 48 by 12, this is 4 divided by 1, which is the same as 4. So simplified fraction is 4 divided by 1. Now, question number 6. We are still on ratios. So here we have a table which we're going to pull our information from to be able to solve this question. So we have to find a ratio of sales at SIFTUS to Corolla and Sons. So this is your A quantity, this is what your B quantity. So your SIFTUS is on top of the fraction, Corolla and Sons is at the bottom. So on the table, we are looking for the sales, the 1 year sales for SIFTUS, which is 810,000. Corolla and Sons is 140,000. Now we need to find a reduced form. You can type this in your calculator. And this gives 81/14. All right, let your calculator do this work for you. Use the fraction button on your calculator, and that will give you what your reduced form of this fraction. Question 7. We are still on ratios. So here we have to find a ratio of utilities to the total budget. All right, so as always, the quantity before the to statement will stay on top, and the quantity that comes after the to statement will always be at the bottom. So utilities, on the table, the cost for utilities is $120, and your total budget is $2,000. So a dollar will cancel out, and now to get the reduced form, you have to type this in your calculator, and this is 3/50. All right, still on ratios. Here we have to find the ratio of A to B. So your A is on top, your B is at the bottom. Now for A, we have 1.4 million per the question. And for B, we have 2.3 million. So million will cancel out. If you divide 1.4 by 2.3, the question says we have to round it to 2 decimal places. So 2 decimal places says 0.61. All right, the next one is B to A. So your B is 2.3 million and your A is 1.4 million. So million will cancel out. And again, you have to always check the instructions in blue because that tells you where to leave your final result. So 2.3 divided by 1.4 is 1.64. Okay, make sure you are checking your rounding rules as well. 2 decimal places 1.64. Okay, you don't want to do all the hard work and lose points for not rounding what correctly. So always make sure you are checking your rounding rule. Now C, A is what percent of B? All right, so we're going to take our answer from part A and then you multiply by 100. And this is 61%. So A is 61% of what B. All right. Now, why are we taking the answer from part A? Somebody may ask. You start with A, all right, and it ends with B. All right. And this is in the form of what? A to B. Okay. So you take the answer from part A and convert it to a percent by multiplying by what? 100%. Now, if this question were to be B is what percent of A, then we would have taken the answer from part B and then change it to a percent. So make sure you are looking at which quantity begins and which quantity ends on the question, and that will help you with what value you need to take to convert to, or which value to take and multiply by what? 100. So the answer here is A is 61% of B. All right, next question is writing a number in scientific notation. And if you are using your calculator, you have to change the mode to scientific mode, and then you put this number in and hit enter. Now, if you're not doing that, per the rule, we have to move our decimal place. We have to move our decimal point till we meet 1 and 0 digit in front of what? The decimal point. So the zeros after the decimal point, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 zeros after the decimal point, and then we have 7, 8. Now, according to the rule, the 1 and 0 digit here is well, the 7. So we have to move our decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then whether this will be positive or negative will depend on the number you're converting to what a scientific form. If this number is very small, how small is small? If it is less than 1, we are saying the number is what? Small. And therefore, making the exponent negative is going to make the number what? Small. All right. And the 9 is how many times you move your decimal point till you meet the 1 and 0 digit. So we have 7.8 times 10 exponent negative 9. All right. Question 10. So for this question, we are looking at how much the government collected in taxes that year. So in 1 year, the government collected about $6,820 per person. So this is the per capita. So the per capita has been given to us, okay? The per person has been given to us. We also know the population. Now, what we don't know is the quantity, all right? So per capita, which is the quantity divided by the population, we have two things given. We can find the last item. So per capita is $6,820 per person. We don't know the quantity. I'm going to use an unknown variable x. The population is 26 million. Now to find x, I have to multiply the 6,820 by what? The 26 million. Okay, we have to apply cross product. So x is 6,820 times 26 million. And it says we have to round to the nearest 100 using scientific notation. So always make sure you are reading the instructions in blue, because that tells you which form to leave your final answer. So we have 1.77, all right, nearest 100, 1.77 times 10 exponent 11. All right, so ignore all the remaining digit after the second 7. All right, it says nearest 100, which is the 2 digit after the decimal point. So all this one has to be ignored, and you're left with 1.77 times 10 exponent 11. All right, now moving on to question 11. For question 11, we need to find how much each worker will be charged. So if the government decided to pay the 18 trillion debt with a one-time charge distributed equally among the 200 million person. So this is finding the per capita or per person. So to find out how much each worker will be charged, we have to divide the debt, which is the 18 trillion. So trillion, we are adding 12 zeros. And for million, to 200 million, we are adding what? 6 zeros. Okay, trillion is times 10 to exponent 12. So you add 12 zeros. And then million is 10 to the 6. And since we don't have any decimal already in the number, we have to add what? 6 zeros for that. So now to simplify this, we have 90,000. And if you divide these two numbers, you have $90,000. All right, question 12. This is a proportion problem. And with proportion, you have to be consistent. You keep the same things on the same side, making sure the numbers you have correspond. So for this problem, we are looking at the number of sweaters and how much they cost. So I'm keeping all the sweaters on one side and I'm keeping all the cost on one side. So for 3 sweaters, that corresponds to 40.95 cents. But for 7 sweaters, we don't know what the total cost will be or how much that will cost. So I'm going to use an unknown variable x for that. So to find x, you have to apply cross product. You multiply 7 by 40.95 cents, and then you divide the whole thing by 3 sweaters. So sweater will cancel out. So your final answer will have a unit of $4. So 95.55 cents. Our next problem. We have to find the mortality rate in units of death per 100,000 people. So to do this, we have to divide the number of citizens that die of a certain disease by the population, and then you scale that value by what, 100,000. Scaling this by 100,000, if you are writing this as a proportion, you have to have your x divided by the 100,000 on the right side of the equal to sign. And if you solve for x by applying cross product, you have 738,000 times 100,000, and then divide the whole thing by 326 million. This is 200, and it says round to the nearest integer. So this is 226 deaths per 100,000 people. All right, so question 14. This is also a proportion problem. So we have to be consistent. You keep the same things on the same side. So for 156 miles, you have 3 gallons of gas. So for 936 miles, how much gas would that be? So 3 gallon times the 936 miles divided by 156 miles. So miles will cancel out. And that is 18. Okay. So your unit is going to be in gallons. All right, the next one is under CPI. And CPI is an application of proportion. So again, we're going to set this up using proportion. So you take the price and then you divide by the CPI for that year. So for $9, CPI for the year 1980 on the table. So we're going to look at the price index. That is what we're going to be using. So 1980 has a price index of 100. So you put that at the bottom. you introduce your equal to sign. Now we don't have the cost for the year 1970, so that is unknown. But on the table, we have the CPI for 1970 to be 29.15. All right, and this is all that we need to be able to solve this problem. So here to find X, we have to apply cross product. 9 times 29.5, divide that by 100. All right, so these are the prices. These are the CPIs. And this is the year 1980. And this is the year 1970. 9 times 29.5 divided by 100, we have 2.66. It says nearest cent. So 2.66. All right, another CPI problem. Question 16. So again, you take the price of 25,000. You divide that by the CPI for that year. So year 1977, the CPI on the table is 60.6. Now equal to, we don't know the price for the year 1998, so that is X. And the CPI for 1998 on the table is 163. And again, to solve for X, we apply cross product. 25,000 times 163, divide that by 60.6. So these are the prices on top, and we have the CPI at the bottom. This is 1977 information, and on the right side of the equal to sign is the information for the year 1998. And solving for X, this is, so rounding to the nearest dollar as instructed, this is 67,244. Question 17. This is a percentage problem, and on the percentage we have part over whole divided by, part over whole equal to P over 100. Now the part here is the number of credit Sharon has earned so far in the class. So we have 24, and the total credit is the 64 credit. This is the credit that she needs to graduate from her community college. All right, so the total credit needed is the whole, so that will be on at the bottom part of the fraction, and the total credit that she has earned so far is the part. Okay, that is part of the total credit she needs to graduate. Now we don't know the percent, so that is X over 100. So to solve for X, you apply cross product, multiply 24 by 100, divide the whole thing by 64. And this is 37.5%. Question 18. This is another percentage problem, this time with a graph and a table. So again, we don't know the percent. Okay, that is what we are trying to find. Now we know the part, and the part is the portion of students who are English major. All right, so the portion of students who are English major is 1,700. And then the total is going to be the total number of students. at Rockford College. So you add up all these values together. All right, you add 4,300 plus 1,900 plus 800 plus 1,700 plus 600 plus 2,700. So we have a total of 12,000 students. Now to find X, which is the percent, you have to apply cross product. So 1,700 times 100 divided by 12,000. This is 14.2% if you leave it to the nearest tenth as instructed. So 14.2%. All right, next question is question 19. And here we have a percentage problem as well. But I wanted to point out one thing, okay? Because this is one of the common mistakes students make on this problem. They fail to find the annual expenses, all right? So on an annual basis, so for this problem, we are looking for the annual lottery expenses. So if Maria spends $15 on lottery ticket every week, at the end of the year, how much is she spending on lottery ticket? So you need to do that math first. We have 52 weeks in a year, so you have to multiply 15 by 52, which is $780. All right, so this is the annual lottery ticket. Expenses. Now we also need to find the annual food expenses. If she spent $137 per month on food, we have 12 months in a year. So at the end of the year, Maria is going to spend $1,644. So annual food expenses. All right, so now that we have the annual expenses, we can go ahead and do the math. So the money spent on lottery ticket is, so we know the is part. So we're gonna put 780 over the off part is going to be the 1,644, and we don't know the percent. So at this point, we have to apply cross product to find our X. And to the nearest percent, we have 47%. So on an annual basis, the money spent on lottery ticket is 47% of the money spent to buy food. All right, question 20. All right, for this question, we need to use this table. So we have to click the icon to view the table of the carbon dioxide emissions in 2012. Now we need to find the part-to-part ratio of Germany to United States. So clicking on the icon, we need to find Germany. So Germany carbon dioxide emissions in 2012 was 788.3. And we are comparing that to the United States. So the United States carbon dioxide emissions is 5270.14. So part-to-part ratios, the quantity that is named before the two statement is on top. The quantity named after the two statement will be at the bottom. So we're going to put Germany's carbon dioxide emissions on top of United States carbon dioxide emissions, and then if you scale this by 100, okay, the question says scale the second quantity to what, 100. So you have to set this up as what? A proportion. So you have X, applying cross product, you have 788.3 times 100, divide the whole thing by 5270.4. And this is 1 decimal place is 14 point. So this is 15 because we have 14.957. So that will be 15 is to 100. So this is 15. So now to interpret this in context, which is the reason part, we are saying that the carbon dioxide emissions of Germany were 15% of the amount the United States emitted in 2012. And now for the C part, this time we are comparing Germany to the whole world. So that is part to whole. So clicking on the icon, we need to find the whole world is 32310.3. We already know the carbon dioxide emissions for Germany from the part A problem. So to write this, I'm gonna put Germany on top of the world. So Germany is 788.3, divide that by the world, which is 32310.3. And scaling the second quantity to 100, you have X over 100. So now to solve for X, you apply cross product, 788.3 times 100, and then you divide by 32,310.3. And we have to leave this also in 1 decimal place. And that is 2.4. Now using that in a meaningful sentence, the carbon dioxide emission of Germany were 2.4% of the world's total emissions in 2012. All right, now the next part is mean, median, mode, which is descriptive statistics. So to find a mean, which another name is the average, you have to add up all these values to get a total. So 53 plus 52 plus 73 plus 65 plus 68 plus 60 plus 47 plus 47 gives a total of 465. And then you divide by how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8. And this is 58.1 if you leave it to 1 decimal place. Now median, this is the middle number. But to find the middle number, we have to first put the values in ascending order. So you have to arrange the data points from smallest to largest. So 47, 47, 52, 53, 60, 65, 68, and then 73. Always double check and make sure it adds to the data values that you were originally given on the problem. So 1, 2, 3, 4, 5, 6, 7, 8. Now that you have them in ascending order, you're going to cross the highs and the lows, and then you pick the middle number. So the average of the two middle numbers, okay, gives you the median. So you add the two middle numbers and you divide by 2. So 113 divided by 2 gives 56.5. And we have the mode. The mode is the data point that appear most often in the data set. So 47 appeared twice in the data set, so that is our mode. Now, which of the following best describes the given distribution? So the different types of distribution, we have right skewed, left skewed, and you have what symmetric data set. Now, if your data, okay, if your graph is not symmetric, okay, the data point is not evenly distributed in the graph, then you either have right skewed or left skewed. But to figure out which one to go with, you are looking at, okay, if you draw a bell-shaped curve around this, we are looking at where the long tail points to, okay, or where the graph is being indented. All right, now you can also make this bigger, can make this graph larger to really see how the graph is behaving. Okay, realize that most of the data points, okay, is going to skewed right. Okay, we have the long tail on the right side, so we have the distribution being right skewed. Now 23, here we're going to look at how to calculate final grade. So this is under weighted averages. So weighted average using the percent weight. So here we have been given the average for the assignment. So homework, we have the test, we have the final exam. So the category averages, we have average for homework to be 71, the test is 64, final is 80. And then for the weight, homework has a weight of 20%. Test is 50%. Final exam is 30%. Now 20% is the same as 0.2. The decimal equivalent for 50% is 0.5. 30% is 0.3. Now for the last column, you take the average and then you multiply by the weight. 64 times 0.5, 80 times 0.3. So 71 times 0.2 is 14.2 plus 64 times 0.5, that is 32, plus 80 times 0.3, that is 24. So if you add up all these values, you get a total of 70.2, and then dividing that by the total weight, so total weight of 0.2 plus 0.5 plus 0.3 is just 1. So 70.2 divided by 1 is 70.2, and that is the student's grade. And this is a C on most grading scale. All right, the next one is GPA. So to calculate GPA, we need to find the total quality points, and then you divide by the total credit hours. So the table we have will help us get the quality point for each of the courses. And then you add up all the values to get a total quality point, and then you divide by the total credit hours. So we have 4 times 3.67. So you multiply each of the credits by the grade scale. So 4 times 3.67 is 14.68. 3 times 2.67 is 8.01. 4 times 3.33 is 13.32. Now that you have the equality point for each of the courses, we're going to add up them. We add up all these values under the equality points to get a total. So you have 14.68 plus 8.01 plus 13 point. So this was a typo. This is 4 times 3.33. So 13.32. And you divide by the total credit hours, which is 4 plus 3 plus 4. And that is 11. We have 14.68 plus 8.01 plus 13.32. We have a total of 36.01. Divide that by 11. Gives a GPA of 3.27 if you round it to the nearest hundredth. Now, last question, which is question 25, is also a GPA problem. This time we don't have the table already built up for us. We have to build our own table and then do the math from there. So here we have point A is 4. If you score a B, that is 3 points. C is 2 points. D is 1 point. F is 0 point. What is the GPA of a student who gets an A in 2 credit course? So we have credit, we have the grade point, and then we have the quality point. So credit, for 2 credit courses, the student had an A, and this is 4. So 2 times 4 is what, 8. And a B in each of 2 3 credit courses. So 2 3 credit courses. This student had what, a B. And B is 3 on the grading scale. And we have 3 times 3. 3 times 3. And we have a C in a 3 credit course. So for a 3 credit course, the student had a C, and C is 2 on the grading scale. So 3 times 2 is 6. And the last one is a D in a 4 credit course. And D is 1 point. So now to get a GPA, you add up the values under the total point. So 8 plus 9 plus 9 plus 6 plus 4 have a total of 36. And for the credit hours, we have 2 plus 3 plus 3 plus 3 plus 4. We have 15. So you take 36, divide by 15, and that gives you the GPA. It says we have to round to 1 decimal place, so this is just 2.4. All right, so these are all the questions. These are all the questions we have on the exam 1 review. Go through it. If it is too long, you can pause in between the sessions, take a break, come back. And if you have any other questions after going through, please feel free and email me. Thank you, and I hope you found this helpful.